Hi, I'm Andrea and welcome to Productive C#. In this video, I'm going to talk about record structs introduced in C#10. Here I have a simple console application targeting .NET 6 and using C#10. I have defined a record class called point that takes an X and a Y, and I have a little bit of code to show you what the records can do. I created a record, I deconstructed, I created another record point 2, then another record point 3 using the with expressions, printing the values of the 3 points, and then printing the result of comparisons between point 1 and 2 and point 1 and 3. And I can show you this works by running the program. You can see the 3 points printed. The first two are equals, and the second one, point 1 and point 3, are different. As you all know, record classes has been introduced in C#9 to help you define immutable classes with value type semantics in a very short and compact way. Starting from C#10, Microsoft also allows you to create structs, record structs, with the same kind of value type semantics and all the benefits that records provide. So let's do that. Before doing that, when you use the record keyword, without specifying the kind of record you want, by default Microsoft is creating record classes. But you can be explicit if you want. You can say record class. And then you can change record class to record structs. The code still compiles and runs and produces the exact same value. So the semantics is exactly the same. What actually changed is that under the covers, the compiler generates a struct rather than a class. There is also something very important to keep in mind. By default, record structs are mutable. That means I can change the value of properties after I created the objects, and I can prove that to you by simply just trying to assign 10 to x of point 3, and the compiler works. So that's very important to know. When you use record classes, Microsoft generates an immutable class with immutable properties. While if you create a record structs, by default, record structs are mutable. And this is being done by Microsoft in order to keep record structs compatible with tuples. However, you can still create an immutable record structs by simply adding the keyword read-only before record structs. And now, as you can see, the compiler tells you there is an error because you can't assign a value to a property after it's been created. So read-only record structs is the way to create immutable records with value type semantics in C#10. Now, there are some other important differences I want you to show you, but in order to understand, we need to get one level down and see what the code the compiler generates. I've done that using a tool called .pick from JetBrains, and I already created the 3 compiler-generated codes for record class, record structs, and read-only record structs. So let's take a look at the code and compare 2 of these codes, these files. So let's start by comparing a record class with a read-only record structs. So I select these 2. I'm using Visual Studio Code for that. Compare selected, and let's have a look at what's going on. Read-only record structs is on the left, and the record class is on the right. So obviously the first difference is that one is a struct and one is a class, not surprisingly. They both have an automatically generated constructors, and they both have getInit properties, so they are immutable. Obviously, as you can see on the right hand side, we have an equality contract that is used in order to implement inheritance in record classes, but on the left hand side we don't have it. That's obviously because structs in C# don't support inheritance, so there is no point to have any equality contracts in there. All the rest of the implementations are similar to string, the comparison operators, and so on. This is something very important to keep in mind for structs. Structs already kind of implement, value copy or value type semantics, but the implementation was actually using reflections in C#. While if you use a record structs, the implementation is effectively written down using C#. So there is no longer use of reflection to do the comparison. There are some benchmarks around showing that you can get easily 10 times better performance by using record structs compared to the default structs behavior equality comparison using reflection. So that's very important to keep in mind. And finally, you can see that the record class has a copy constructor, while the record structs don't. That's also because record structs already kind of support the copy semantics. And that's kind of it. So the difference between read-only record structs and record classes is effectively just the fact that one is using record, and one uses structs, and one is using class. So you can choose between the two as you would normally do between choosing classes and records. You probably want to use a struct if you want to have stack allocation, you want to have locality when you create arrays, and usually when you have a smaller memory footprint. Otherwise, you probably can stick with the classes. Now let's compare a read-only record struct and a record struct. This also won't surprise you. As you can see, they're both structs, but one has read-only fields and the other one has mutable fields. On the left-hand side, we have the read-only record struct that has get init properties. On the right-hand side, we have the record struct that has a get set properties. And that's actually the main difference between the two. All the other differences are mostly simple metadata. So let's wrap this up. Starting from C#10, we now have three types of records: record classes, record structs, and read-only record structs. The difference between the two, between the structs and the record struct and record classes, is of course that one is using structs and one is using classes. But the most important things to remember is that record structs by default are mutable, and you need to use the read-only keyword to make them immutable. Also, if you use the record keyword on its own, by default is using record classes.